Good morning, Aryabhata Sahu, sir.
Okay, let's wait for Chakraji to join. So today Chakraji again joined, I think so.
Yes, sir.
minutes में हम session.
So dear participants, we are facing some technical issues. So we will be starting the session in another 15 minutes. From 10:30, we will be starting the session. Good morning, Pawan Kulkarni, sir. Sir, you are in mute.
Please unmute yourself. Hello, Pavanji. So, welcome. So, thank you for accepting our request. So, we're not able to hear you. Yeah, now we're audible.
So, my voice is clear now?
Yeah, now your voice is clear. So, thank you, Pavan.
Okay.
Pavan Kulkarni. So, thank you for accepting our request. Okay. So, dear participants, so it's Pavan Kulkarni. So, today he will. Hi. So let me start my video also so that we can see each other. Point of view.
Yes.
So today we talk about extraordinary research environments, research in special conditions experience, sharing for aircraft and sea expeditions in Antarctica. Very means how to do research in very difficult environments. So we'll talk about that, and he have very good experience in run this thing. So expedition. So let's listen from Dr. Pawan Kulkarni. So please take over. Pawanji, please take over.
Okay, let me try. Yeah, please. Thank you. I am not sure whether the link is proper because I'm finding it difficult, but still I will try to upload the content.
You can share. Once you can share your content. So
You can share.
Can you please authorize me to share videos because that is not working as such. I would like to upload a presentation and then we'll start with my presentation. My share link is not working.
So you can open PPT maybe. So if you have PPT, then you can open and share. So you have permission to share your content.
Pardon?
You have permission to share the. You have permission to share the content. You can present your screen.
The thing is, my share option is not highlighting, allowing me to share anything. 1 minute. Share screen. Okay, so I'm sharing my screen. Just give me a minute. Yes. Is the screen visible to all?
So,
hello?
Not yet. Not yet.
I already shared my screen. Just
sir, it is not visible. Now it is coming up.
Is it now?
And now this screen is coming.
Now is it visible?
It's not. Yeah, now it is visible.
Because here.
Now it is visible.
Now it is visible. Okay, so yeah. Okay. So thank you organizers for providing me this wonderful opportunity to interact with the members of the academic community to share some of my experience that during my Antarctic expeditions and various expeditions that I've been part of. And believe me, I'm sure for last 7-8 days you might have heard a lot of things, a lot of mathematical equations, experimental methodologies, and a lot of things that are done in science, particularly in research, when it comes to when you are back in your laboratories doing a lot of stuff and coming up with wonderful research activities. But one of the challenges of research is also field work. And when it comes to, and particularly in case of researches such as uh, atmospheric science, air pollution, you have to come out of the comfort of your laboratories and uh, go on the streets or isolated locations. Even I'm not anyway saying that working in laboratories in research institutes is a easy job. Definitely, that's also very challenging. If you are working in a confined space anywhere globally, it doesn't matter. It's a challenging job because the uncertainties that are present anywhere you go are huge. And one has to deal with all those uncertainties, whether you are on road, in field, or in a laboratory. However, when you are in research laboratory in a confined space, challenges are different. But when you are in the field or you are on road doing some measurements and those kind of stuff, dealing with people, then it's a totally different set of skills that are required. What we are trying to say here is the skill sets required, the conditions that you face are totally different when you are working inside the premises of a research institute, and then when you are working in field or in the on road or dealing with people. So here at this point of time, what I am going to do is I am going to speak about challenging conditions in research, particularly in field work. So I will move on to next slide. So my research journey started back in 2003 when I joined National Physical Laboratory as a research scholar. And my journey actually started at a very nice note because I was being selected as a winter member for Antarctic research. Very few people globally get this opportunity, and it's a wonderful experience. And a thought of visiting Antarctica, a very clean, icy, pristine site for your research, can be a dream come true for a newly postgrad student, which was my case. And then I moved on from Antarctica. I was on sea cruises, ocean-based measurements. I was into aircraft-based measurements. I was been on islands, not only Indian islands, but also foreign islands. Like I was in Kaurati Islands for installation of a Calwell system. Then I was in Azores Islands of the Portugal, and a lot of places that I visited. And all these are beautiful, hilly, mountainous regions with clean, pristine environment. And then, as you know, you cannot be on these sites forever. You have to come back out of the dream. And then I did my research remaining work in National Physical Laboratory in New Delhi. Now, all of you know that a lot of newspaper articles coming out, CPCB reports coming out, Global Watch people are saying that Delhi is nowadays one of the most polluted cities in the world. So my journey has seen the extremities, not only in terms of temperatures, because when I left Delhi to join an Antarctic expedition, the temperatures were anywhere around 30-40 degrees. And when I reached Antarctica and I seen the peak in Antarctica, it was like minus 40 during the winters. So not only in terms of what you say temperature, but also in terms of living conditions, the pristine or clean sites, I've seen the extremities. I can surely vouch for that. So this is the journey that I have gone through in my research for last 15, 18 years. And I will be sharing those experiences with you with some word of caution and how it is done, why it is done, what is the importance of this kind of event. And believe me, I know you guys all know your science. You don't need to hear it from me. And that's what you have been hearing for last 7, 8 days. people telling you how to do your research. So today I'm not going to tell you what to do as such. I'm going to share my research experience and give some pointers, I would say. I would not even say instructions or something. I will say pointers which are very important when you are in the field, because I'm a field person. So I will move on. So the Guru Mantra for researchers, scientists, while working in challenging conditions, as you know, safety first. See, what happens is a small accident or anything can ruin the entire expedition or an experiment, depending where you are doing it. So, whether you work in a laboratory or in Antarctica or any place in the field, what comes first is a safety. Because unless you are safe and you are in best of your health, some activities cannot be taken up. Same is the case with experiments in field, particularly in highly isolated places such as. Second case is mental and physical strength. This is particularly required for people who are working in the field, particularly in places like Antarctica or any other ocean expeditions or land-based expeditions, if you talk about. Because mental strength, because you are in isolation, uh, a closed team of 10, 12, 15, 20, 25 people working together, people with different views, people with different backgrounds, people with different ideologies come together to form an expedition. It's not like because the common platform is science for all. It's nothing else. It's only to serve science. They are with you in that expedition, but they come with various backgrounds and ideologies. So in an expedition, mental strength is very important because you have to be very strong uh, mentally to choose on what topics you want to talk, what topics you just want to avoid, so that the harmony doesn't get disturbed in a closed environment in an expedition. Similarly, physical strength is required because you don't carry porters around with you on an expedition, at least not in terms of Indian expeditions, because we cannot afford that and that's not required. So when you are working in isolated conditions, all the hard work required, particularly moving instruments, conducting logistics, fixing your instruments in the field, calibrating them, taking measurements. All these activities need to be done by the scientist himself or the researcher himself or the team of people that are part of that expedition. And so physical strength is definitely needed. And apart from that, you cannot say कि this is not my experiment, so I will not touch his instrument or her instrument, and I don't want to deal with that kind of stuff. No, it's not how it is done in the expeditions. You are a part of a team. A clear-cut analogy can be a cricket team where a bowler cannot say that I will not perform a batting duties. If required, he has to bat. Everybody has to field. Everybody, specialist bowlers, if gets injured, couple of them, then non-regular bowlers have to do the bowling job. So similarly, a scientific expedition with a team involved, everyone has a defined role and they are responsible for their roles. But at the same time, they have to do additional duties which are probably not their expertise, which probably they are not part of, I have not done in their life, but under the guidance of who is leading the expedition or who is the lead of that experiment, everybody else has to work. See, in my situation, it happened a couple of times that I was the most junior member of my Antarctic expedition. I just freshly graduated, did my master's 2002, and in 2003, I was on my way to Antarctica. So, and my expedition leader was GSI director, and he was almost like 54 years of age. But at certain point of time, I told him, I need this to be get done and please help me out in this. At that point of time, I was leading that particular small group, a task in which leader of my expedition was a part. He was a member. And apart from that, even after he being 54 years of age, almost more than double of my age, it doesn't matter, because I was the one who was responsible for my experiment. So I was lead of that particular task and he had to listen to them. So you have to keep your egos away when you are in a team, when you are a part of an expedition. So physical strength, mental strength, both are a must when you are on a
Somehow we are not able to hear you. Pavanji.
out in field, and particularly in challenging conditions, you are not supposed to go alone.
So there is some issue with actually bandwidth. So sometimes your voice is breaking and sometimes we are not able to hear you.
Because imagine you are in Antarctica, and I hope everybody is must be aware of gas chromatogram kind of a system, and you forgot to take your calibration gas or some backup ferrules or some piping or a diaphragm, a very small thing. A pump has a diaphragm which is made of mostly rubber or sometimes silica, and you are not carrying one or two spare diaphragms with you. Over the period of year, definitely it's going to have some wear and tear and it gets damaged. What are you going to do in Antarctica? There's no shops, there's no alternate arrangement. You cannot just simply put a requisition back in the store that I need a diaphragm, because there's no store. It's all your responsibility. It becomes the member's responsibility to see to it that in one go, all the required components that are needed for your experiment are done, and then you assist your team leaders and others in doing their work also, to make sure that everything gets doubly checked, so no one is forgetting anything. Because at the 11th hour, you simply cannot do anything. You just, then that entire observation year or that expedition gets spoiled, or your experiments are not conducted just because you forgot to take a diaphragm with you, which cost not more than 50 rupees, 100 rupees for sometimes. But that 100 rupees can cost crores of rupees when it comes to Antarctica, or you are doing some expedition in the deserts or on the mountains. Because planning, execution, everything, there's a lot of investment that goes behind this, and a small mistake can cost a lot of money. So planning to the T is very important. So these are the guru mantras of uh, challenging, working in challenging conditions. Now this is what is few pointers. Then I will move on to my how we did, where we went, started our expedition, where all we went, what kind of observations we did. I will come to that now. Now, as you all must be knowing that Antarctic research in India, particularly nowadays, in last 5-6 years, it's not just Antarctic, but Arctic and Antarctic research in India is coordinated by NCAOR. Here you can see it's an old logo from my expedition 2006. I particularly went twice there, once as a winter member from end of 2003 to mid of 2005. And then second time I went in end of 2006 to mid of 2007. So in total, I might have spent more than 20 months in 2 stretches in Antarctica, once as a winter member and once as a summer member. So at that time, National Center for Antarctic and Ocean Research was coordinating all these activities. It comes under Ministry of Earth Sciences, Government of India, and it is headquartered in Goa. But now they have changed it somewhere around 2012, if I'm not wrong. Now it's NCAAOR, and it stands for National Center for Arctic and Antarctic Ocean Research and Ocean Research. So now it has, instead of just 2 components, Arctic and Ocean Research, it also has Arctic, Antarctic and Ocean Research. So moving forward, now this is all just a background. You might find it repetitive, but still, where is Antarctica? Antarctica is South Pole. It's a very clean, pristine site. Almost no landmass is connected with Antarctica. As such, Antarctica itself is a landmass. Now, a small point here, in the Arctic, you don't have a landmass. There's a frozen ice altogether till the bottom. Here, there is a landmass which is covered by ice, entirely covered by ice. Almost 98% of Antarctica is covered by ice. There are only 2% of landmass is exposed to atmosphere, where there is no ice accumulation around the year. That part might also get covered in the ice during the peak winter periods or when there is blizzard, but otherwise mostly that 2% of landmass is exposed to atmosphere. Rest all Antarctica is covered with thick blue ice, very hard ice. And Antarctica is unique again because it has a dome shape, and at the center of Antarctica, more or less, the ice thickness goes as big as 4 kilometers, 4,000 meters. So a dome with on the peripheries a couple of meters to almost 4 kilometers at the center. So it forms a dome-like structure. And because of this dome, what happens is there's a prevalent katabatic winds that flow across Antarctica. Because with gravity and with temperature structures, wind flows from top of the dome towards the outer edge of Antarctica, and the wind speeds can pick up almost more than 100 nautical miles. I'm talking here in terms of nautical miles because that is the standard notation in meteorology and WMO. That's what is used. But to convert it into kilometers, it's 140 kilometers per hour. So it's almost like 140, 150 kilometers per hour winds can blow, and this is a very regular phenomenon. It's not that it's an isolated event. It's more or less regularly irregular phenomenon. As you can see here, Antarctica is more or less a comma-like thing, where South America is the closest to the Antarctic tip. Otherwise, all other countries, the nearest can be again New Zealand, Australia, South Africa, because they're all being in southern hemisphere, are close to Antarctica, and we all being in the north, we are not close to Antarctica. Now, geographical South Pole and magnetic South Pole, as you might have heard of this, both the terms. There are two poles, but geographical pole or South Pole, a physical pole, is almost like 23.44 degrees tilted, has a difference of this much degrees from magnetic pole. So they are not at the same location, the geographic pole and the magnetic pole. And as you can see on the slide, they are almost like 1800 miles from each other, the true pole and the magnetic pole. Rest of the geometry we all know, so I will not just go into the nitty-gritties of what is Tropic of Cancer and what is magnetic pole, what is geographical South Pole, and angle of rotation and all. Now here comes the plane of revolution. As you all know, Earth is bit, particularly it's not sphere in shape, even if it's showed everywhere. It has a slot flattening at the poles and a bulge at the equator. And similarly, it rotates not in the center, but our axis is bit tilted. And at the same time, the angle of rotation around the sun is also not in a plane of sun, but it's bit tilted. It's the celestial equator in which generally the Earth rotates. Now comes the important part, which dynamically changes, by the way, the mode of transport. When initially the expedition started in 1983, a closed group of expeditioners under Qazi Saab started from all the way from Goa. That time from National Physical Laboratory, Dr. Sen Gupta was part of that expedition, a very genuine and very brilliant scientist because I interacted with him when I joined Antarctica, and we shared a lot of experience together before and after, because he was more or less of my age. My age means when I went for Antarctica, which was 24, 25. And when he went for his Antarctic expedition, he was a new recruit in National Physical Laboratory, joined as Scientist B. So he was very good to me, and he called me to his lab. He was Scientist G when I joined NPL. During all this period, he might have sent so many people to Antarctica, but when I joined him, he called me to his room and he said, "Oh, you are almost of my age when I went to Antarctica." And I said, "I'm lucky one to be part of this expedition." And he gave me so many pointers and explained me so many things about Antarctica, which helped me a lot in my stay in Antarctica, in my experiments in Antarctica. So initially during the 83-84 period, the expedition started from Goa. Through Mauritius, it used to go to Maitri station, and it was all through and through by ship. But then this used to take a lot of time and efforts. The expedition travel component, transport component itself used to be like 20, 25, 30 days, depending on the sea conditions and other various parameters. But then slowly, as the India started maturing and gaining other experience in Antarctica, they started exploring other ways of transport, so that this journey and to Antarctica can be reduced, so that researchers can spend more and more time in Antarctica rather than spending time in travel. So they came up with a new route, that is to fly from Goa to Durban, Cape Town, and from Cape Town to Maitri, they started going by ship. So this journey from Cape Town to Maitri is generally 7 to 10 days, again depending on sea conditions. So I was part of this kind of expedition, in which my first expedition, in which we traveled all the way from Goa to Cape Town, and then Cape Town by air, and then from Cape Town to Maitri by ship. And let me tell you here that logistics is the most important part in entire exercise, because Antarctica is an expanding, dynamically changing continent. In summers, the sea ice all melts and you can reach till the shelf of the Antarctica continent. But as the winter sets in, water around the continent starts freezing. I will show some pictures of the same. And then it starts expanding. And this sea ice can be as thick as 1 meters and more, and it can extend a few hundred kilometers. So your ship cannot reach till Antarctica. So you have to transport all your experiments, goods, man, food, anything you think of, including the large amount of fuel that is needed to work in Antarctica for running generators for electricity, for production of heat, for cooking, anything and everything you imagine in terms of energy, you have to transport to Antarctica in one go. And that particular fuel is ATF, aircraft fuel, because it has a property of anti-freezing. Normal fuel will not be is useful in Antarctica. So aircraft fuel is sent to Antarctica, and that too also in one go. You cannot say that I will ask a second serving in somewhere in the middle of the winter. That's not possible. And then again, the confidence of India grew, and then now there is a direct two components of the expedition last 10-12 years, in which men and scientific cargo is sent from Bombay direct to Maitri by flight through Cape Town. Whereas supplies, particularly fuel, because you need large quantities of fuel, more or less like 400 to 500 KL fuel is required. So this fuel and food is sent by ship, whereas all the cargo is sent by ship, and scientific cargo and men are transported to Maitri by flights, because that saves a lot of man hours, and scientists can straight away start their expeditions the moment they reach to Antarctica. So next slide. Now some beautiful pictures. All my presentation is going to be with beautiful pictures from Antarctica, from mountains, from aircraft-based measurements. I am definitely not going to show you any slide saying E is equal to mc square, or any Heisenberg square equations, or Euler's equation, or any kind of those equations. No, that part has already been taken care of. I've been told that we have already burdened everyone with lot of equations and lot of that stuff. Today, what you are going to tell is show some good slides and show the other side of the research, which is also equally important. So this is Emerald Sea. This is a ship in which I traveled. I traveled till Cape Town by flight, South African Airways, and then from there we took this ship. And this ship can carry all the fuel required, that is more than 400 to 500 KL of fuel, plus all the food articles which are required for the entire expedition of 13-14 months, plus all the scientific cargo, plus all the researchers, scientists, and army personnel, because our army personnel in our time, army was involved in this for logistical purposes. Just information, Antarctic continent is no man's land. No one has any sovereignty over there. There are claims, of course, each and every square inch of land over the earth has been claimed at a certain point of time. So Antarctica is not untouched. There are claims from US, there are claims from Argentina, Chile, Germans, Europeans. I don't think Indians as such have any bigger claim, but still we also say that this part of Antarctica belongs to India, because Antarctica, India was part of Antarctica, and then it got detached and Gondwana land moved towards Himalayas. So historically we were connected with Antarctica. So this part of Antarctica is ours. These kind of claims are there. Germans just during World War I or II, I'm not sure, flight over Antarctica, threw some flags in some areas, and they started claiming Antarctica is there. French reached there, said this part is ours. Australians and New Zealanders, being closest, they reached there, they started claiming some portion of the land. But then Antarctic Treaty was formed, and through Antarctic Treaty and SCAR Committee, Steering Committee on Antarctic Research, froze all claims. So as on date, there is no claim which exists which says this particular piece of land in Antarctica belongs to such and such country. There are claims, of course there are claims, but they're all freezed. And you are not supposed to do any kind of explorations except scientific ones in Antarctica. So you cannot just go drill there, explore oil or natural resources buried under that Antarctica. See, there are definitely natural resources because it's a continent and a big one. 1 lakh 14 million square kilometer of area. So it's a big continent, and there is a land beneath it. And definitely there is going to be one or the other kind of natural resources present there. So everybody is nowadays interested in rare earth materials or some kind of resources which can be used some industry. But all those claims are frozen. You cannot do any kind of exploration activities, mining activities in Antarctica. What you can do is experiments. You can study. You can say this part of Antarctica is rich in this particular kind of mineral, that part of Antarctica is rich in coal, that kind of Antarctica is rich in nickel, copper, whatever you can do studies, but you cannot explore them. At the same time, you can do drilling, but it's not that you can go and keep on drilling everywhere. You need to get certain kind of permissions through which only you can do drilling, and you can do your studies there. So first picture shows the Emerald Sea in which I traveled. Second picture from a helicopter, which again is Emerald Sea. The third one, that is left hand side bottom corner, a strip you can see, that's an airstrip. It's a makeshift kind of a strip. You cannot have a permanent airstrip in Antarctica, particularly on ice, because with blizzard, lot of snow drifts. Like similarly in deserts, sand dunes keep on shifting. Similarly here, ice also keeps on shifting because winds are so strong that they take away the upper part of ice because of friction, and they move and dump it at some other side. So this happens all the time. So there cannot be a permanent airstrip, but every year uh, near Russian station, they manage this airstrip, and from there only we started bringing our men and cargo through aircraft to Antarctica at Maitri station. Maitri station and Russian station are like 2.5, 3 kilometers away from each other at line of sight, and we are the nearest of the stations. The next third nearest station to Maitri is almost like 600-700 kilometers away. So we are the only two neighbors there on Sumachar Oasis, which is a land exposed site, which I will again show you in the photographs. And this is a ALC aircraft which brings in the supplies at the start. The aircraft operations can take place just during the daylight hours. You cannot have, because it's a dark airstrip, there are no lights or anything to guide the aircraft, and there is, as you can see from the picture, there is no tower to guide the aircraft where to land, how to land. So you don't have a 24-hour, 24/7, 365 days kind of aircraft operations. Hardly 8 to 10 sorties take place from Cape Town to Antarctica because it's also a costly affair, and in which particularly life-saving things. Suppose you need medical emergency supplies, that too in the summer part of the expedition, that can be brought in by aircraft. If something goes bad in the winter time, station has two doctors, and whatever limited supplies they have, you have to take care with that. Even if something big happens, there is no way that you can send essential supplies during the winter months when there's no more sun. You won't believe that in one of the expeditions, earlier stage, they used to send just one doctor. And in one of the expeditions, the doctor himself got appendicitis. So what was he going to do? There was a do or die time for him. He operated on himself through some guidance from back home, through teleconferencing kind of a thing, with the help of Germans and with the help of expedition members. He operated on himself. So these kind of things do happen in Antarctica, and since then India started sending, and it more or less became a mandate in which all the expeditions were supposed to send two doctors. But even with the presence of two doctors, if something goes wrong in the middle of the night, Antarctic winter, there's no way out. You have to deal with that situation then and there. If someone gets a fracture, those two doctors will fix it. If they need some metal implants to be put into and that is not available, no issues. You just don't put implants. You just do the temporary plaster, whatever is possible. Or you come up with some innovative ideas, which always take place. So this is the kind of circumstances that you can face in Antarctica. So that's why I say that when you are working in challenging conditions, safety becomes first, because you don't want to deal with that kind of accidents. Then mental and physical healths are important. Your body system is very important, so that at the right time alarms can be raised. A very good example, as I just told you about the doctor, if you would have a buddy doctor, then he might not have to go through all that trouble. And similarly, all other things. Next slide. Now, you might think, how many stations are there? Oh, there are more than permanent stations spread across Antarctica. You can see they are scattered all over the map. And you can say these two dots are very close. No, this whole continent is very big. Now here you can see I have shown you Maitri station, and just next to that the dots are more or less overlapped, and that's Novolazarskaya station. We used to call it Novo station because it's very difficult and long pronunciation to call Novolazarskaya. So they are more or less overlapped and they are 3 kilometers away. And the very next station, Sane 5 South African station, is 600 kilometers from there. So you can imagine the distances between the stations that are spread across Antarctica. And this is something which is very deliberately also happened, I would say, serendipity. No one decided to be spread across Antarctica, but it's a blessing in disguise, because this way the spread gives you data from various points, and then extrapolating it to a certain level, you can get the true picture of Antarctica instead of all stations clustered at one point and you are talking about entire Antarctica. That's not how the science is done. So next slide. So here I will start with various Antarctic stations. So as all of you must be knowing, Dakshin Gangotri was our first research base in Antarctica, which was installed in 80 to 83 summer period. It was a temporary makeshift kind of arrangement because it was installed over a ice shelf. Ice shelf is nothing but it's beneath the ice shelf. There is no landmass. It's basically an extended portion of Antarctica which is frozen, which can be as thick as 60, 70, 80 meters, and below that there is water. So this particular station was built on the shelf, and when this shelf breaks away from Antarctic continent, that's what forms icebergs. Okay, so when icebergs are connected to the continent, they form the part of the shelf, and when they break up away from the shelf, that's called iceberg. So the Antarctic first station, Dakshin Gangotri, was on ice shelf, and with time, over the period of next 18-20 years, because of its self weight, this entire station got submerged in the ice. So this station no more exists. There are only pictures, that too with few people, few floating on internet, and few with very rare people who were part of first 2-3 expeditions have very nice pictures of this station. Rest all is history. There's no more Dakshin Gangotri station that exists there. So after this, but this we knew from the beginning that we are building this station, Dakshin Gangotri, on an ice shelf, which is going to get submerged in the ice. So why was this built? Just as a makeshift arrangement. And then very after 2-3 years, in 80-85, Maitri station came up. Maitri is second Indian Antarctic research base. Now I will show you that. This is Maitri station, second Indian research Antarctic base. And now you can see here, this station is based on rock bed. it's not on the shelf, it's on the continent, on an exposed part, the 2% part. It's not 2%, it's just the Sumatra oasis. Entire Antarctica in the peripheries and in the mountains, totally combined exposed part is 2%. This might not even be a fraction of that. So on this particular landmass, there are two stations. One is Maitri station and second one is Novo station, Novolazaraskia. And this station was commissioned in 1895. It's still date in operations since it's being on land rock. Needs all the time some kind of maintenance now because it has gone old. It has seen lot of rough weathers, but still this station is there. There is already a proposal in floating to build a new Maitri station, Maitri 2, and dismantle this particular station because it is getting old and is getting prone to accidents. So there is always a activity that is still going on there, but slowly people are trying to move away from this station and build a new station, which might take some time. So this is our second station, Maitri station. We also have a third station now called Bharti station, which recently came up in 2009-10 by the end of my PhD. By the way, just not bragging, but just telling, I was also part of that expedition which went for initial recce land surveys, in which it was to finalize the place for the commissioning of third station, which I will again show some photographs and tell you more about it. So this is our third beautiful state-of-the-art latest station, Bharti station. And the beauty of this station is Maitri station is almost like 80 to 100 nautical miles from the shelf inwards, because you have to cross all the shelf and then you reach the continent rock bed, and then there is that station. So this travel is done through choppers, and you don't do it all the time. Only once you reach the shelf by ship, as I said here, you reach the shelf. From here, men and cargo, scientific cargo, is transported with the help of choppers. I will show that. And other goods like food and fuel is transported by piston bullies, a special kind of trucks that can run on ice. So but here the benefit of this particular station, which was a strategic decision at that time, that we will come up with a third station where the ship can almost come as close as to the station, or station to be right on the place where rock is exposed to the atmosphere and is connected to the ocean, not to the shell. So as you can see here, very unique picture where ship is almost anchored near the station. So here the logistics become very easy. You don't need too many activities to carry out to complete the logistics. So this is third and the most latest of the stations that we have in Antarctica. So now coming back to Maitri. Now you can see these are various views of Antarctica, few land photographs taken by me and some aerial photography done by me. So first picture, right, left hand side top corner is a Maitri station, which has a beautiful view. On the backdrop you have glacier, in the front you have rock base, and in front of that, as you can see in the next picture, right hand side top corner, there's a lake. And let me tell you, this lake also gets frozen during the winter. And then as you can see, there's a duct line that runs from the lake to the station. This duct line, if you leave some water inside that, that also gets frozen. So what is done is this whole duct line is uh, emptied each time the water filling activity is done. You don't leave any water inside the pipes. At the same time, when this lake gets frozen, we have put some heaters inside the water where there is a pump. And during winters, when this whole water gets frozen, you start those heaters, you melt water, Then you pump that water to the station, inside which the temperatures are maintained around 10 to 12 degrees, depending on the season, because you start getting acclimatized, and even during winter at 15 degrees Celsius, you start feeling hot. And then you start saying that temperatures can still be reduced, and a man can easily survive in the temperatures around 10 degrees. Absolutely no problem within station if there's no wind chill. So as you can see, I told you about the water thing, and this lake in front of the station is called Priyadarshini Lake, named after our Prime Minister Indira Gandhi, Priyadarshini Lake. And as you can see, there are a lot of hutments scattered around the station. So just to let you know that these are all called fuel dumps, where fuels are stored. In the right hand side bottom corner, you can see a lot of fuel dump drums. It's not small drums, it's the trailers which are there. Then you can see some containers in which there are generators. They are kept away from each other, because if one accident happens and if one of the generators catches fire or some untoward thing happens, you need backup system. So there are almost like 8 to 10 generators, and always working in tandem, one at a time, so that if something goes wrong in one, second can be put up, and there is always a maintenance job going around. So there's complete 2 people are assigned just for this task. And then you can see there are yellow colored hutments. They are called summer camps, because the station has a capacity to accommodate 25 members only, not more than that. And then it has a kitchen and some cold storages and all. Cold storages, I will come back to that, because in Antarctica cold storage sounds a bit strange, but still you need that, just because it's not that temperatures are cold, but still they have fluctuation. Temperatures in summer from somewhere around sub-zero, -1, -2, to go down as low as -40 during the winter, 40, 40. But for food to remain intact, not get spoiled, it's not just that the temperature should be cold, but they should be steady temperatures. So whenever you go to some cold storage, it always shows -20 degrees, ±1 or 2 degrees, not more than that, because fluctuation more than that will spoil the food. So you need cold storages for your food articles, frozen food. Then you have summer hutments, because as I said, at any given time, main Antarctic station Maitri can accommodate 25 people. But during summer period, when previous expedition is about to leave and next expedition comes in, and when there is this overlap period when handing over, taking over takes place, at any given point of time, there can be max to max 95 people present in this particular site. So someone just popped some message. I think some of this might be known to a lot of people, but I'm sure at the same time, a lot of people might not know about it. And some of the small stories that I'm been telling you, it's not over internet. So it's a good idea to just listen to me, and I will be there to answer if there are any queries. Some interesting facts can always be there. So at any given point of time, 90 to 95 people can be there during the summer period. So you need to accommodate other people, those who are there in the transit as next summer team, next winter team, as well as current summer team. So the summer team and the next incoming winter team is accommodated in the summer camp, and previous winter team remains in the station. Once they hand over everything to the next summer winter team, then they vacate and they move to the ship. Summer people completes their expeditions, and with previous winter team and current summer team, everybody comes back to India, and next winter team remains there to carry forward the scientific task that has been designed and assigned to them. And then in the left hand side bottom corner, you can see a small is basically till I was there in touch with Antarctic expeditions, was handled by EME group of army. There are two kinds of groups of army that used to visit with us. One's from engineers and one's from EME. So EME people were basically for electrical, mechanical maintenance kind of job. They used to come there. So next slide. So this is again different view of summer camp. And as you can see, all these huts are being placed at a particular distance from each other. They are not connected into one block. Someone can ask, why so? Because fire is a very big hazard in Antarctica. Why so? Because it's a cold continent. It should not be. No. Cold temperatures has nothing to do with fires. What fire has to do is with fuel available and second, dry conditions. So Antarctica is one of the driest place on earth. There's no moisture, almost no moisture, one of the driest place, as I can say. And there is, all the structures are made in wood and there is enough oxygen. Believe me, it's a very oxygen rich because there's no pollution. So all the ingredients that are required for a fire are there. So to avoid fire hazard, and even in case something goes wrong, not entire, the whole camp should not be endangered. So all these summer camps are scattered here and there so that if some part catches fire, you have something to fall back on. So, and you can see here Mount Abu named hut, which was basically a communication hut during the summer period. And as you can see, Maitri station also has a dome on top of it, which was again recently installed, and Mount Abu was dismantled. And this now is our main communication hub. Now again, a small interesting story, probably will not find somewhere on internet. Initially, when I visited Antarctica, or previous team of mine, they had 6 minutes of talk time per month per person. 6 minutes. So in an entire month, if you want to call back to your families and get to know what they are doing, how they are, they used to get 6 months, 6 minutes time period per month. And in that 6 months also, there was no guarantee that the connectivity would remain good. So it was horrible. So it was more or less like if you went to Antarctica for next 1.5 years, you are totally cut off from the mainland. And then came our expedition. And we got 12 minutes of time. All the previous expeditions were so angry with the government that how come you are giving 12 minutes of time? You can see the luxury of time for telephones in Antarctica. 12 minutes of time in 1 month to talk to your families, whereas we got only 6 months. But then the bonus 3 minutes were given to them and blah, blah, blah things happened. But we were lucky enough to have at that time 12 minutes of time per month to talk to our families, everyone. And after that, if you want to call to your families at a paid kind of thing, which was also not that I will pay money, so let me call. That were also some restriction. And then you would end up paying like 1,000 rupees per minute or so. Because it's all through sat links that this telephone connectivities were maintained. And that were not Indian satellite. The transponders were from some other countries. Somewhere around, if I'm not wrong, again, 2008-9, ISRO dedicated one transponder on one of its satellites for Antarctica. And now the luxury is, they have better internet connectivity than probably what we might be having here. Because at the start of this presentation, at least I was not able to clearly hear what was being said. And it took some time for the internet to get set up. But I can tell you, they have sometimes live streaming, live chats with their children and families back home from Antarctica. So the better and better connectivity and technology is coming up. But at the same time, that was not the case when I was part of the expedition. So coming back now, some other facts. can someone tell me, am I doing good with time or I need to hurry up?
I think so.
Is it okay?
Yeah, we started at 10:30, so we'll have a break sometimes maybe.
You want to break, or in the next half an hour I can wind it up?
Because people may feel a little bit of very, um, if it is very long, then people will feel a little bit bad. So it's better to give a very at least 10-minute break maybe.
How much time do I have? I was told around 1.5 to 2 hours.
Yeah, so
We
that's
can
similar.
break for 5 minutes if you say so.
Yeah, maybe 5 minutes might be very small, but 10 minutes will be better.
Praveen Kulkarni sir, your lecture was from today's was originally scheduled from 12 p.m. to 2 p.m. So it was a 2-hour lecture. It was
Yes,
scheduled.
yes, you are
We
right.
started around 10:40, so it is already 1 hour over.
Yeah.
So
See, guys, I have a lot of material. I can keep on talking to him, believe me. That's not a issue.
no.
The thing is, I started early because Dr. Chopde, who was supposed to take from 10
yeah,
to 12,
he
he is in some travel or something.
some
So
travel
I
he
was
was
asked to
good, but I was not.
prepone my presentation. So,
Mhm.
but okay, we can stop for 10 minutes and meet after 10
Then we
minutes.
can start. Yeah,
So let's take a small break and let's start after 10 minutes. Is that okay?
yeah, that's fine.
Okay. Thank you. Thank you, Shaw sir.
Yeah, thank you.
So I will leave this slide like this and we can meet after 10 minutes.
Okay, sir. Thank you, sir.
Okay.
Maybe you can switch off your video, maybe, or maybe mute.
Hey, Gansham. जागरण करून दे ना.
So hello, Dr. Kulkarni. So can you start now? So you are on mute. So please unmute yourself. Please unmute yourself.
On your end. Yeah, thank
Yeah.
you. I was trying to unmute myself, but I was not able to do so.
Okay. So we can start now. Again, restart.
Yeah, आप आदेश करें.
Yeah, sure. So
Yeah.
please.
Okay, so where we left is on this side where I should, 1 minute, let me put it back on presentation mode. Give me a minute. Yeah. So we were on this slide where I just showed you that this is a summer cap and all. So one of the very interesting and intriguing part of Antarctica, as you all know, that people keep on saying this, Antarctica has 24-hour sunlight and 24-hour night time for 6 months and 6 months period, which is actually not true. Probably you are all aware of this, that as we move polewards, on the pole itself, this is more or less correct, but some part of the time there will always be twilight. But as you move away from the pole towards the coastal Antarctica, instead of being on 90° south or even 90° north, if you are Maitri station is around 70° south. So here basically the total dark time period is around 60 days and total sunlight time is around 70 days. Intermediate period from summer to winter and winter to summer, you can have a varying degree of daylight hours and night time. So basically when the summer ends and winter starts, sun sets for a few minutes and again comes up the horizon as a sunrise. And this sunset period can be initially for 5 minutes, then it slowly starts increasing and it then reaches 24 hours of sunlight period, sunset period. And then you have a complete darkness for almost like 55 to 60 days. Even if you remove all twilight and all those things, you get a total darkness period of around 60 days. And then comes the most interesting and awaiting part of any expedition is the first sunrise, which is almost is just for 5 minutes or maybe even less than that. First sunrise is even less than that. Everybody eagerly waits on their windows or in the common places from where sunrise can be seen on the deck or in the open outside station, just to take a glimpse of the sun, because sun just pops up and goes down. So this is the first sunrise in Antarctica, just for a few minutes. And then again, on the very next day, the sunlight period increases by 2-3 minutes, and this keeps on happening. And again, after say of 70, 80, 90 days, you get a complete sunlight, 24-hour sun on the horizon. And it might sound a bit stupid, you can say so, that one day I decided myself that let me see 24 hours sun. So what I did, because it's not possible that you can be there outside watching sun 24 hours. So I set alarm for every hour. I was 24 when I visited Antarctica. All that excitement was there, that impurity was there, that let's check it, let's do it attitude was there, which as a bad thing I'm saying, which goes away with the age. We start saying that people start getting mature, but that childlike feeling goes away, which I still had at that time, at the age of 24, 25. So I one day, against all suggestions, I decided, everybody started saying that it's science, it's established fact and blah, blah, blah. And I was like, no, I just want to see it once, because this is going to be a one-time opportunity to do so. So I just kept on going outside my hutment. I was doing my experiment in the physical laboratories lab, hutment. and I was going every hour, almost every hour, just to go and see the location of the sun. And you won't believe me, I did saw sun rotating along the horizon and not setting for entire 24 hours period. I was so happy. Means I just cannot put it in words, and I don't know what everybody will appreciate that feeling or not, but I was very happy. That was like, yes, I've seen this. Very few people in the world might say so. And similarly, the temperatures in Antarctica at particularly Maitri side, the coldest temperature ever recorded on this earth ever is minus 89 degrees at Vostok station, which is history you will find everywhere in internet. But at Maitri station, we saw minus 41 minimum temperature. These are daily average temperatures, so don't go on these numbers. These are daily average temperatures that I have plotted here. But the minima that we saw was minus 41. And daily minimas were 2-3 degree minus and that kind of things. So during summers, the temperatures can reach as close to as 0. And then during winters, that can drop as low as minus 40. So these are the graphs for daylight period and temperatures as I have shown you here. Probably you might not see this kind of a graph in net. And now this is what I was talking about. First sunrise and first sunset. The upper picture shows first sunrise pasted in such a way that it's not one image, it's multiple images clubbed together. And you because we set the camera there and we took pictures at every interval of a minute, and then we clubbed it, and you can see actually the sun just comes up and sets. And similar is the situation when the night starts and sun just dips along the horizon, and again after a few minutes it comes up. So this is also a wonderful experience. This is all science. You see, there's nothing new that I'm talking about. But seeing that happen is something very joyous. Some of you might be wondering, I'm not talking science, but please don't mind. I have n number of presentations with me on climate change and air pollution and ozone hole phenomenon, because I was there to study greenhouse gases and ozone hole in Antarctica on behalf of National Physical Laboratory. Published a lot of things, but I'm not here to talk about that today, at least, because I was been asked not to. So this is the general things that we are talking here. Next, now these are the local mode of transport. During summer, you get choppers, because along with ship, 2 choppers comes to Antarctica, generally hired from either Australia or New Zealand or South Africa. They come there to serve us. Generally 2 choppers. As I said, even in choppers, there's a buddy system, because if one chopper goes on a sortie somewhere and some problem occurs and it's not reachable site, then you all have to have a backup chopper, first to rescue men and then to rescue the chopper. So buddy system works everywhere in Antarctica. So even choppers. So this is the chopper that we had during our time, was from Australia, and 2 beautiful Australians stayed all along with us for the entire duration of summer period. They used to say, oh, we love Indian food, but they hardly tolerated the kind of spices and hot food that we eat, and they always used to complain about that. But they were wonderful people. And similarly, the second side, you can see a piston bully. It's a truck, but it can run on sledges, and secondly, it runs on ATF fuel. It's not regular diesel or petrol vehicle. It runs on ATF fuel and totally automated, and can be controlled very easily. I drive it for some time, very short distances, because we were not supposed to drive this. But as you know, yaar ek chakkar de de, and then you drive for 15-20 meters, 100 meters, that kind of a drive. But it's fun driving these vehicles. And these are particularly used for sorties. As I said, at our time and currently also at Maitri site, all the logistical items, particularly food, fuel, and heavy equipments, are offloaded from ship onto the shelf. of which the pictures I will show. And from shelf to almost like 120 nautical miles land route, these piston bullies tow those vehicles or logistical items, and they bring it to the station on trailers. So these particularly vehicles are used for logistical operations for the movement of men and material. Now here you can see the whole logistical operation. You can see that on the right hand side top corner, a underslung of a chopper. So mostly men, the moment scientists reach the shell, those who have geological surveys to be done, those who have immediate summer experiments to be set up, they are first flown to the station. Then their cargo, the scientific load of the expedition is underslung. Those which are manageable are sent by chopper to the Maitri station. And after that, during the winter period, as and when required, there can be at the most 8 to 10 sorties. Sorties means bringing in a trip from station to ship is called a sortie, and not one vehicle but 10 piston bullies go in one go, and then they bring backloading all the stuff to the station. So this is how sorties are done. So as you can see on the second picture on left hand side top corner, that a piston bully is attached with a trailer on which there is a fuel tanker. This way fuel, as well as you can see right hand side bottom corner, there are some cabins and containers which contains the food and other kind of items, scientific items that need to be transported, are transported along ice and land to the station. And in the left hand side bottom corner, you can see the activity of offloading stuff from the ship to the shelf. This is the most, I'm quoting it here, the most difficult task in the logistics, to offload fuel containers and food item containers and any container from ship to the shelf, because this shelf is very slippery, so and has slope also. So here you can see just one trailer and one piston bully, but there are two more piston bullies anchored further in the front, because if something happens, this trailer will slide and can go in between the shelf and the ship and go down into the ocean, and then it's lost. So, and these booms of the cranes of the ship has a particular length. They cannot go beyond that. So first operation is to find the most suitable site for anchoring the ship, which is as close and as flat a portion of a shelf. Because if it has edges, then the whole ship will not get aligned. So a flat and without slope and straight kind of a shelf is recceed first, identified, and then ship goes there, anchors itself where there is a minimum gap between the ship and the shelf, and then slowly these containers and fuel tankers are offloaded onto the trailer, and that trailer is again anchored by a couple of vehicles in the front. And once this activity is completed, the trailer is moved as quickly as possible away from the shelf, because there are three problems there. One, the slope. Second, the slippery surface. Third, most important is there is always a chance of shelf breaking away from the continent. As I said previously, that shelf is nothing but ice, 60-70 meter thick ice. And when this shelf breaks away from the main continent, they form icebergs. But there, you might think of icebergs as only big structures, but that's not the case. Even a small chunk of ice breaking away from this shelf can form an iceberg, but which will immediately get melt within few months, and it disappears. But this possibility is always there. So a very thorough recce, a thorough survey is very important, identifying a site and then offloading all the cargo. Because if you lose a tanker of fuel, that's 20 kl of fuel, that is kiloliters of fuel. You receive almost 400 to 500 kiloliters of fuel. And if you lose couple of them, you will be shortage of fuel during the expedition. So you just don't want to lose the fuel or any food article. If suppose a container containing all the frozen item is lost to sea, what will happen then? Then you will have to survive on whatever is left. So a very careful logistic operation is done during this time, and one of the most dangerous logistic operations. Now let's come to living conditions in Antarctica. We will be talking about clothing, food, station insights, and IT unit, and there are various sections I will cover one by one. So first comes the clothing. This is very one of the important aspects. As you know, I told already that -40 can be a very usual phenomenon in the winter, but one has to get out of the station, because my laboratory was not inside the station. It was more or less like 100 to 200 meters away from main station, 150 to 200 meters from main station. I had to walk daily from my room in the station to the laboratory 200 meters and come back, and this activity never stopped even in the peak of the winter. Only this activity stops when there is a blizzard, when winds are above 150 kilometers per hour. There's a snow flying everywhere, visibility is almost zero, and on top of it, station in charge or the expedition leader issues a warning that no men will go out of the station from this point onwards till further notice. It's always till further notice, because you never know when that blizzard is going to stop. And whatever maintenance activities of the generators, particularly of the generator, all laboratory experiments and everything comes secondary, because safety is first, as I said. In any expedition, particularly in Antarctic expeditions, directors of the institutes, even NPL director, not only at an individual level, but Antarctica NCR director in Goa, department secretary, that time it was DOD, then becomes Ministry of uh, Earth Sciences. Even secretary issues this saying safety first, experiments second. So you have to follow it, because no one is going to take risk there, because there's no meaning. If you lose couple of days data, that's okay, but you cannot lose your life and put whole expedition into some problem. So advisory, or I'm using word advisory, which is a bit soft. It's instruction, strict instruction, not written in that word, is put on the board saying no men will leave the station except the generator people who have to maintain generators even in those conditions. They have to, because if the generators fail, the entire station supplies will go off, and putting back generator on is a difficult task. And during that time, if something happens, then everybody will be in problem. So the process of taking generator men from station to generator, which was like 50 meters, used to be an expedition in itself. All 20 people, 24, 25 people on high alert. Then there used to be a rope and torches every 10 meters, 15 meters, giving light indicators saying he, at our time it was generally all 25 male team, but then there was some occasions when there were few females on the expedition. So they walk few meters, they signal that second person can come, third person can come, and this way that person goes up to the generator, do small maintenance work, whatever that is to be done there, and they are brought back. And it's that all 25 people at that particular time has to be fully awake, fully dressed, so that if something goes wrong, everybody is on their toes, ready for rescue. That's the kind of alertness that needs there. Firefighting suits. I was there's a firefighting team which is always designated, and fire drills takes place. We are taught all this in Goa for how to handle fire cylinders and those kind of things, how to utilize that. I was of two-man team was there, again buddy system, who were trained for proximity firefighting. we were trained in wearing that firefighting dress, which is a hell of a job to do in itself. And that too within a given period of time of 2 or 3 minutes. You have to wear that all firefighting suit, and then you have to go to fight the fire. You are not supposed to approach the fire as and when and however you feel fit. There were teams who will do what job, who will supply cylinders, who will operate cylinders, who will do it from a distance, who will go near the fire. This all is already on the paper. Only thing is you need to execute it, as I said, to the T. So I was part of the firefighting team, proximity team. So within that short period of time, we had to wear all those firefighting dress wherever we are, run to that point where that dress are stored, wear it, and then approach the fire for fighting. So clothing is very important aspect. So as you can see, this yellow dress, they are called dangris, overalls. Uh, and this is more or less the fifth layer of clothing. The topest one that you can see in blue color is the fifth layer of clothing. The innermost is your innerwears, on top of it your thermal wear, on top of it another layer, then there is woolen dangri, and on top of this dangri. This particularly shields you from the air. Air will not go inside this, and then internal wears that you all have protects the heat that body has generated from escaping out. This is how you protect yourself. And then these shoes, white shoes, the middle person is Ram Magan from my expedition, is wearing are called sorrel shoes. You can see three kinds of shoes, one brown shoes, two white shoes. They're all special purpose shoes. This photo was deliberately taken like this with different footwears, because this brown color shoes are for certain tasks, more or less to walk on rock surfaces because it has good grips. These sorrel shoes can have very good thermal isolation. And again, these particular white shoes are more or less very good thermal isolated working shoes. So at each time of the period, what kind of task and where are you wearing, what is the situation in the station, you are supposed to wear all these things the moment you are stepping out of the station. Inside the station, you don't have to worry because there are heaters, blowers, inside temperatures are maintained, and inside you can be with couple of layers of clothing. But the moment you want to go out, you are supposed to wear all these things and then only go, and that too in a buddy system with a walkie-talkie and with a torch and everything. Means going 200 meters from residential area to the laboratory used to take more time than I take in Nagpur to come from my place to my office, which is like 8 kilometers away. Believe me that. Currently, I'm in Nagpur. I stay almost 8 kilometers from here. It takes me 20 minutes drive and 10 minutes here and there. It used to take more time to travel 200 meters because the preparation itself were 10-12 minutes. And then you start walking slowly towards your station and then come back. With all those heavy gears, it becomes really difficult. So next, now this is very interesting part, kitchen. As you can see, this is our cook. Again, in 25 people, there is one cook always. In summertime, there are two cooks because one is from previous expedition, one is from the next incoming expedition. And they are tasked with cooking food for all the team members. But to help them, two members are assigned on a daily basis because cook is the only person who has to cook meal for 25 people all the 3 times. All others can get some break at some point of time. If some blizzard is going on, I can, and if a leader has issued a notice that no one will step out, so you have more or less like an off day there. But cooks generally don't get an off day. So, and they have a very huge routine task of cooking food. So they are allotted 2 people to help those who are called on galley duty. So task of these 2 people is to help cook in preparing lunch, breakfast, dinner. That's again a very interesting question asked all the time. How do you follow time? because there's no sunlight sometimes and there's sunlight sometimes, and then there is no followed sunlight sometimes. So there's always a clock, and it's always recommended that you follow clock so that your routine doesn't get disturbed, you get a sound sleep, and you are motivated enough to do your day-to-day job. Because if once your sleep pattern gets disturbed, then the entire schedule of the station starts getting affected. Because if you are sleeping in the day and daytime as per clock, and you are awake during the night time of the clock, the cook will get confused, the food supplies will get confused, the duties will get confused. So to avoid that, it's always suggested, but then there are always people sleeping off hours and then creating problems, but then there are mechanisms to take care of that. And the right hand side bottom corner picture is not kitchen area, it's particularly a small cabin which is taken by the sortie peoples, army peoples, when they do sorties, to travel almost from the station to the shelf and come back is like more or less 5 to 6 day task. Because those piston bullies, even if they look bullies and very tough, they travel without load at 10 kilometers per hour speed, and with load they can travel 5-6 kilometers per hour kind of a speed. You can imagine to cover 80 kilometers takes a day, 80 to 100 kilometers, and then loading everything on the trailers and hooking it up to the piston pulleys and bringing it back to the station takes a lot of time, days. So they need to have a place to stay and place to cook. So this part of the picture is where there is a small kitchen where pre-cooked food, packaged food from DRDO and other places is generally taken, and they are heated and consumed. But even for drinking water, a glass of water, you have to fetch ice from outside, bring it in, melt it on the gas, and then consume it. You can imagine you have a luxury of just going to some dispenser and get a glass of water. Simple. But here, to get a glass of water, it's an activity. It's a assigned activity. It's like today it's Ram Magan who will do it. Tomorrow this is Major Chitendra will do it. If Pawan Kulkarni joins the sorties, then Pawan Kulkarni's task today's morning will be to fetch some water, liquefy it, and make it ready for the drinking. It's a task. Because again, you have to go out of the cabin to a place where expedition people are not going, because then you have all the messed up ice there. Try to bring fresh ice, melt it, and keep it ready for consuming 3 times a day. So you can imagine the life. Small task which we just don't care back home becomes a difficult task when you are on an expedition. So you have to be very careful. Now this is coming back to the station. This is the internal area. Left hand side picture is of our galley, where basically all team meetings, cultural events, entertainment things, everything was in this room. This place has an accommodation for nearly 25 people. Whenever some guests visit, during the summer period, you usually have some people visiting from Novolarzarskia station or from some other expeditions flying in to do the visits of the station. SCAR committee coming for inspection. And even during winter, if like we have 15th August, similarly, no people have during the winter hours, June, July, their Freedom Day and all. So they come to our station, we go to their station. This kind of exchanges are there. And this is what keeps you motivated and interesting in the whole expedition. And this is the dining area where 25 people have their food. Now this is more personal of a thing. This is my room on left hand side top corner with me in the picture. It's a very small room, 7 or 8 feet by 10 feet kind of a room, where with one bed, one cupboard, and some personalized stuff. And this is handed over from one person to another person as and when we move. Second picture shows the corridor Third picture shows the hospital area, the dispensary area, which has medical equipments and all. And on the fourth picture, you can see a small corner dedicated as barber area. I rarely used it. The moment I went to Antarctica, I took haircut once and someone messed with me my haircut because no one is a trained hairdresser. So one guy helps other guy in cutting the hairs. I tried my hands at couple of people. They scolded me. They tried their hands on my hair and they spoiled it totally. Then I decided I'm no more going to have haircut, and won't believe I had no haircut for more than 1 year, and I had my haircut after coming back to Nagpur. When I returned to Nagpur, I had more or less 1 feet long hairs. My mother refused to acknowledge it's me, but then I had to convince her that it's me. So I was looking totally different. In one of the pictures, you might see that. So these are the photographs of the station. So now, again, we Indians go anywhere, we need our gods, wherever, whichever faith we follow. So you can see here, uh, there's a small temple. You call it temple, masjid, mandir, church, whatever. There is all different uh, gods from different religions are there. And even if one of the particular expedition doesn't have a Christian or a Muslim or a Hindu or a Jewish or whatever, but still that corner is always maintained and always taken care of. It's not that if there's no Christian in the expedition, you will just avoid that area. No, the whole area is again designated to someone, and then that person is responsible for the total upkeep of that entire area, irrespective of what god he follows, or if he doesn't follow the god, it doesn't matter. The good part of our expedition was there was a Deshpande Saab, which you can see in the right hand side top corner, one with uh, not wearing anything on the top. He was responsible. He was a religious person a bit, so he was given responsibility to take care of all the temple area, and he was equally taking care of the god temple, the Quran area, the church area, everything. So this kind of harmony is also very much required. That's why I said at the start, mental strength is very much required. If Deshpande Sahab would have said, "Ki nahi, nahi, ye to mera nahi hai, main nahi karunga," then everything gets messed up. So you need a person with a very balanced mind in such kind of a situation. Next, now the interesting part. You might have heard a lot about auroras. Aurora australis, aurora borealis. Borealis is northern hemisphere. Australis is your southern hemisphere. And believe me, they are very beautiful. Some might have seen it. Those who might have gone to Canada or Scandinavian countries for their research work through their universities or some grant, they might have seen it if they are there during the winter months. But they are real magic. A large scale firework without pollution, with dancing colors. Even we preparing artificial crackers, we cannot create such a huge, we should not, it's air pollution, believe me. But even if we try to, we cannot attain that grandness that aurora australis or aurora borealis has. It has beautiful dancing colors. And if you are lucky enough, the solar activities are high enough, because this is all solar magnetic play. So if there is proper solar flare, solar activity, active solar cycle period, and you have enough influx and upper atmosphere is getting disturbed, which is a bad news if someone doing his research in telecommunications. He will swear that one of the most problematic issue for telecommunications is solar flares and those kind of things, and that is what is causing this Australia aurealis and Australia borealis, and they are very beautiful. Even if they are beautiful, they are very dangerous for telecommunication systems. And thank to God, because of our magnetic fields present, physical phenomenon, if someone says God, if someone else says, we are very much protected from this destructive power of the nature because of presence of another powerful nature of magnetic fields. If those magnetic fields would not have been there, these activities would have spoiled the Earth's atmosphere and we all would have been impacted. Not to the extent, but yes. And similarly, if ozone layer would not have been there, then there would not have been any life on this planet. So these are few things which are very important in geophysical aspects, but this is how it works. Now some beautiful pictures of icebergs, caves, sculptures that are found there. Some of these are available on the net, but I'm going to show the photographs that we took and the importance of each. Now icebergs. Icebergs are again part of the shelf that gets broken off, as I said, and start floating if you are in south towards north, and if some chunk of ice from north Arctic region breaks off and starts floating towards south, they are called icebergs. They are dangerous because they causes accidents and they are very big hazard to shipping industry. We all know what happened with Titanic. But if they remain, they are very beautiful. If they remain in their own geographical area and we are not approaching those areas, we are not approaching that areas, they are beautiful. And as you can see, this is all ocean. This is not lake, but oceans in the right hand side bottom corner. It stands still. You can see the complete replica of an iceberg in the waters. Okay, so this is very beautiful pictures that we have taken, and we have just not taken, we were there. I was there when these pictures were taken. They are so beautiful. And now these are different things. Ice caves, blue ice, one of the toughest, strongest ice. If you want to break through and take a chunk of this ice piece, it's a very difficult task. Then similarly, you can see some ice sculptures because water gets freezed even when it's flowing because of low temperature. Instantaneous freezing because of big difference in temperature can occur. So in left hand side bottom corner, you can see below there is water, but on top of it there is all ice. And on right hand side bottom corner, you can see some sculptures of ice getting formed, and the dynamics of this structure is very interesting, and there's a complete and a dedicated scientist working on the dynamics how these sculptures are formed. This is basically depends on the wind temperatures, wind speeds, how instantly the temperature has fallen, what dynamics was there at that particular time, defines the shape and structure of these sculptures. And there are institutes working on this. And then this is now I'm going to see how the ice sheets are formed over oceans along the what you say the shelf. Ice left hand side top corner, you can see, you feel as if someone has spilled some oil on top of ocean water, but it's not oil, it's greasy ice, small ice crystals getting formed, and they are translucent. So that's why you get an effect as if there is an oil spill. Then this starts getting accumulated and forming big patches, and that's how you get the next picture where you have pancake ice. You have greasy oil ice, then you have pancake ice. Then when this pancake ice starts getting collected and getting connected with each other, forming a big place, then you get the third one where you have patches of ice, and then actually you get a sheet. And in the fourth picture, it's a term called Shastrugi, which is wind sculpture. On a sheet of ice, when wind blows, like in deserts, ice also gets blown away with high speed, and it starts creating beautiful sculptures. So these are called Shastrugis, which you find generally in Antarctic region, because you need vast ice sheets and high wind speed, which is generally found only in Antarctica, not in other places, because in other places you do have ice, but on mountain tops and not in a flat terrain. Then we come now. I kept on repeating Antarctica is a dynamic continent because the size of the Antarctica increases and decreases. And here you can see that in more or less March, April, it's of smallest size, February, March, April, depending on the dynamics of that particular year's temperatures. You get February and March as the most ice-free part of the year when there is more or less no ice sheet around the continent. Ice shelf will be there, ice sheet will not be there. Then slowly, as I showed in the previous slide, greasy ice starts forming, then pancake ice starts forming, and then ice sheet starts forming. And the Antarctic continent size grows almost as much as double of the original size somewhere in the month of July, August. Again, depending on the temperature conditions of that particular year. And then again, after that, that ice starts melting because of rising temperatures. Everybody knows, but still I will repeat. July, August is the summer period, winter period in Antarctica, unlike Northern Hemisphere. And January, February is summer period in Southern Hemisphere. So that's why January, February period are sunlit period with minimum ice. July, August are nighttime period with maximum ice extent. Now wildlife, people say there's not much wildlife in Antarctica, but there is small, not as rich as Amazon forest or Indian forest per se, but there is quite a bit of wildlife in Antarctica. And you would not believe Antarctic waters are the basic building block of food chain, because most number of small fishes which are consumed by bigger fishes, and that food cycle starts in Antarctica. If you boom the Antarctic waters with some kind of ions are added, but other food, the fish boom takes place, and that influences the entire aquatic life around the globe, because they are the basics, bottom of the pyramid of food chain for aquatic life. Now here is the list of wildlife that's found there, and believe me, I've seen all of them. Penguins, snow petals, skua is a bird, seal, all you know, and whales are mostly found in southern hemisphere, and some of the varieties of whale are found very close to Antarctic continent. Now here, different penguins, there are so many different varieties of penguins. Small ones are called Adelaide penguins, which are very common around our station region. And then the ones with a very beautiful color around their necks are called emperor penguins. They are huge. They can be as tall as 5 feet or even a bit more than that. And they are very strong and they are dangerous. You are always suggested not to go near them because they can attack you. Even Adelaide penguins that grow almost like 1.5 feet. Wildlife Act, Indian or global, says you are not supposed to disturb their habitats, you are not supposed to go near them, but they sometimes wander around and come towards station, and then you see them and you try to go close to them, take some pictures, which is prohibited, but still sometimes that do happen because you are not going near them, they are coming close to the station because they are wandered, and then somehow in fear or whatever, they try to come near you for some kind of food, because near station they always find some food. And then this white bird is snow petrel, which is a very interesting bird. Just give me a minute, please. Excuse me. Are Ghanshyam, कल्याणीला म्हणते नंबरवर फोन कर म्हणायला त्यांच्या. Hello. Okay, so this is a snow petrel, which is there. It's a very beautiful white bird. One of the birds found. It's one is this, and another is skua. This is skua, pair of skua. All these birds, penguins, they come to Antarctica during the Antarctic summer, and they lay their eggs. They hatch them, and the babies are born, and then they fly at the end of that summer. They fly back at the end of the summer. So most of this aquatic or even wildlife doesn't stay in Antarctica during the winter's time. They stay there for summer time because they are used to that cold weather, and they go away from Antarctica in search of food for the winters, but they don't fly to other continents which are hotter, but to nearby regions where they can get food and they can stay alive, and again come back to Antarctica for their summer period. So on the left hand side top corner skua, right hand side top corner snow petrel. Then there are whales, as you can see in the pictures. This is not my picture, but this snail is picture from one of my colleagues, and these bird pictures are again from colleagues or mine. It's a long time. I was in Antarctica in 2004, so can be mine or not. Now scientific laboratories. At last, after 1.5 hours, maybe we will come back to science, because some part of science I have to tell. Otherwise, some Gaurav ji or someone will say कि साहब आपने तो science के बारे में कुछ बात ही नहीं की. So we will talk a bit about science, not much. So this is me installing instruments in the field, and then these right hand side two pictures are my laboratory, in which there's a GC. We were the first, not me, my boss, who installed this instrument, and then it continued over the period of 3 to 4 years, 5 years. I was the last one of this series of experiments. But this particular GC was installed there for the online measurement of greenhouse gases, particularly CO2, methane. And then there is CO analyzer and other instrument, but GC was first there. And we were the first to have on-site continuous measurement of CO2, methane, CO. The rest, all the countries, including Australians, Americans, they do flask measurements. What they do is, at every interval, they collect air, atmospheric ambient air, in pre-evacuated vacuumized flasks. Sorry, vacuumized flasks. And they store them in a particular condition. They bring it back to the mainland, and then they do their analysis there, which might take some time. There might occur some changes, minor, but that can definitely occur. And that's how the measurements are done in Antarctica at that time. I'm talking 2003, 2004, and this continued more or less like till 2010. And then people started putting up online measurements, because instrumentation, controls, internet facilities started increasing. So remotely monitoring instruments and controlling them is much more feasible now, but it was not at that time. So we were the first to do online measurement of CO2, methane in Antarctica, published some good results. Same is with CO. And bottom red dome that you can see is what is summer hut installed in Antarctica, but this hut was tested there for the first time, because this was supposed to be used after one more expedition in a new site, that is Bharti site, because we were supposed to go there for land recce's. And when you go for land recce's and surveys, you cannot do it from ship. So we were given this hut to test here. And then since I was part of this, I was given also the task to go with the next team in the 26th. I was part of 23rd, and then I was part of 26th, in which we took these huts to the new site. We installed it there, and then we stayed in the hut. We conducted few scientific experiments there, along with other geological people, geological survey, atmospheric survey, blah, 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 meteorological people. There was a bunch of people doing their experiments, plus land recce's, identifying sites. We stayed there for hardly a month, not more than that. Summer expeditions in Maitri are generally for 3 months, but in one of those experiments, we curtailed our summer experiments in Maitri. We went to Bharti station site, and we conducted experiments there. And in this particular expedition, we traveled all the way from Goa with ship, because we had a lot of things to carry with us. So from Goa, we went to Mauritius, Mauritius to Durban, Durban to Maitri. We did our experiments in Maitri. From Maitri to Bharti station. Bharti station, we again offloaded all the cargo and we did our experiments. And then from Bharti, we came back to India through again Durban, Mauritius, and to all the way to Goa. This whole thing was more or less 4 months time, of which we were on sea for almost like 2 months. We spent 1 month in Maitri, 1 month in Bharti, and rest of the time we were all on ship doing. Those who were not having any task to be done at ship, they were not doing anything. But me, I had assigned the task of having sea wavage measurements. So I was also doing my sea wavage measurements in on route to sea. So here you can say this is meteorological laboratory in Maitri. You can see the working conditions where there's a small blizzard. It's a very small blizzard where the visibility is few tens of meters, but still some work has to be done. So that person is doing. And in the bottom two pictures, you can see there was activity of ice core drilling. I was support staff in this because everybody works, and ice core drills up to, if I'm not wrong, 800 meters was done in those experiments. And then these ice cores were brought back to NCR. NCR has a very beautiful ice laboratory which can work on ice cores and ice-based things, because science is known to you. These ice cores carry air bubbles carry ancient air. Ancient air can be removed, analyzed with high precision GCs to know what was the concentration of greenhouse gases and other gases during that time of the era. As you go deeper in Antarctica, the more ancient air you get. So people have drilled almost like 2.5 kilometers more than that. But Indian expedition last known fact for me was around 800 meters. And this analysis was already done and published, and all the science required was done. But it's a very interesting job because removing a tiny bubble, 1 mm kind of a dia bubble or half a mm kind of a dia bubble, without allowing it to get in contact with the external air, you take it out and you inject it into a high precision GC, and then you come to know the exact concentration of air at that particular time, how it was. It's a very beautiful experiments to be done. Now, all this is okay, but being men, you need to be also have entertainment, celebrations, visit. So this part starts now. So this is me with long hairs. During end of 25th expedition, 23rd expedition and start of 24th expedition, that time Minister for Science and Technology Kapil Sibbal Saab visited Antarctica. It was a very big news cycle in India. He probably till date is the science and technology minister that visited Antarctica along with his team. He firsthand got experience of how we have a life there. He visited in summer, not in winters. So, but even in those harsh conditions, he was there. He came to know the tough life that we have to live there as Antarcticans. I take pride in calling that, and all Antarcticans do, because not lot many people can call themselves Antarcticans. So he visited there. So me interacting with him, giving him the details of the experiments I was doing. I was also doing ozone hole measurement. So he was very curious of greenhouse gases and ozone hole. He's a literate man. He studies a lot. So he had very interesting questions about global warming and climate change and ozone hole. And I tried to explain to the best of my capabilities what it is. He was satisfied, at least by the looks of him. I think in the picture also it's clear that he's focusing on my answers. So it went well. Then the one of the pictures is my birthday, which falls right in the middle of Antarctic winter, July 29. So we had a small celebration that time. Then this is my Russian friend who visited on my birthday from his station to our station, because somehow they had planned visit during that time, few people, so they visited. So we really had a good birthday party of mine in Antarctica. One birthday, just one. And when someone visits, particularly the Russians, because they are the frequent visitors, and we visit there. So this is the time to show the cuisine to the outsiders, to serve them well, because in case of emergencies, it's Russians that help Indians and it's Indians that help Russians, because we are neighbors just away at 3 kilometers. So anything happens, we are at a call's distance in Antarctica. Even during tough times, we can visit that place. So that's why we try to teach, we try to impress, we try to help, and we have very cordial relations with Russians. This is one of the pictures of 26 January, in which you can see the leader of the 24th expedition. He is not leader of the 23rd because he had already moved to the ship after handing over the station. I was retained back because the minister's visit was there. And since I was the last one to move all the entire NPL experiment back to the mainland, and that was one of the major successful experiments. So everybody right in the NCOR and ministry decided that I should stay back, continue that experiment till the minister's visit, and then wind it off. So and this is one of the reasons. Second reason, I was active and he liked me, so he said Pawan Kulkarni is going to be retained with us till the time the last sortie is not sent to the ship. So I overstayed my stay in Antarctica for a couple of months, other than my other members who came along with me, because they moved all in December end to the ship, and I almost moved back to the ship by end of January. Now this is Antarctica. Here what is my Antarctic presentation, Antarctic experience I conclude. And then after PhD in 2009, I moved to Portugal for my postdoctoral research. I stayed in Portugal for almost like 8 years. Sorry, if I'm out of my time, please tell me whenever I need to stop, okay? Because I will keep on telling stories. I have a lot of them. So I will just continue. So aircraft-based measurements. So when I reached Portugal, apart from Antarctic and air pollution measurements on land, I was given this task of aircraft-based measurements. Because I'm a measurement person, I like instruments. I know how to deal with them, their maintenance, operations, their health, calibrations, data analysis. So when I reached Portugal, my boss somehow, I don't know, from CV or other things, could identify my expertise. And then he said, Kulkarni, we are starting a new branch of aircraft-based measurements, and I want you to take lead in this. So there's a conference of UFAR, which is also a COD training program. You will, on behalf of our university, you will, and on behalf of Portugal, because I was only one from Portugal, you will go there and join them, learn the things, come back and try to teach other students, those who are doing PhD, so that this can continue. So I was given this task of aircraft-based measurements, which I learned in those particular days. So this is the particularly National Science Foundation USA aircraft. There were almost like, it was a inter-comparison campaign. It had three objectives actually. It was inter-comparison campaign. It was aircraft-based measurements, also training program. All was clubbed together because aircraft-based measurements are a costly affair. So you cannot isolate that this time I will do training, this time I will do measurement, this time I will do something else. It doesn't happen that way. You have to bring entire thing, you have to make a shole out of it. You have to bring all the masalas together to get a super hit campaign. So it has everything, and it had almost people from 15 different countries: USA, UK, France, Germany, Portugal, Spain, Norway, few more. I think one was Russian also. So there were a lot of people involved. So we did some aircraft-based measurement. I got trained on that. So as you can see me here in a instrumented aircraft, life in an aircraft is somehow complicated for me because it's very small, restricted place, restricted movements. I love trains because you can roam around. But in flights, you just simply cannot. But still, you can have a bit of a freedom. But in a instrumented flight, as you can see here, there are hardly seats. In total, in that whole of the aircraft was completely emptied. Few seats with computers and desktops were fixed. I think there were like 8 seats there. You can, in the photograph, you can see just 6, but there were 8 seats with all the computers and all. And on the just on your other side of the alley, you generally have co-passengers. I had all the instrumented racks with all the sophisticated instruments with high response time because aircraft moves fast. I don't need to tell that, but your instrument needs to be faster than that because it's all GPS coordinated. When you say at this particular coordinate, air parcel had this concentration of ozone, this concentration of short-lived gas. Long-lived gases are well mixed. It doesn't matter in a very in few kilometers how much they are changing. Short-lived gases definitely, aerosols definitely. If there's a fire or something and you are studying volcanic emissions or fires, then it becomes really important how they are doing dynamically. So your instrument needs to be much more fast in response than the speed of the aircraft, because then you start telling them in this particular parcel of air of 1 meter by 1 meter or 10 meter by 10 meter, this was the concentration of gases. So you need to know how to handle those aircraft, and you cannot have 10 people working on one thing. Every component, every instrument, there are meteorological instruments, there are gas based instruments, there are physical sampling instruments, there are different disciplines that work together. If someone is expertise in flash from forest fire or volcano, someone is expertise in black carbon, I was there for ozone and methane and other kinds of gases, short-lived NOx, SOx, and ozone. So those instruments are your responsibility, and you don't have backup here. For science part, buddy system still exists. Buddies will be there, but your buddy will not be expert in what you are doing. You cannot replicate experts. Buddy system is for logistics and other purposes. So you have to know your instruments, your science. If something is going wrong, your instrument is giving erratic readings, you should know that this is error and this is science. And unless you don't know, you just cannot get onto a flight, because after a complete flight experiment, you come back and say, oh, my mistake, this is all error because instrument was not working fine. That whole experiment is lost. So then and there, you have to tell your team, everywhere there's a team leader. You have to inform your leader that this particular instrument stopped working from this time to this time. It has this trouble. I can fix it in flight. Can you take one more round? This kind of things must be handled then and there. Calibrations need to be done real time, because if the things are changing dynamically, your range of the instrument should cover it. And if the range of the instrument is covering it, every range bifurcated into small parts need to be calibrated. It can be 1 point or multi-point calibration depending the kind of experiments you are doing, but you need to know that. And that's how you get onto these kind of planes or this kind of expeditions. So these are different aircrafts. Almost I flew on 3 of them. The small one I could not because the time of the expedition was almost over. But I could fly on all these 3 beautiful small aircrafts. And the fun was they all were flying very nearby each other because it was also an inter-comparison experiment. So you cannot have 2 flights flying 50 kilometers apart. Then how can you do inter-comparison? You have to be very close to each other because you are more or less sampling the same air parcel. So they were flying very close by each other. You can see air flight and you can actually wave at someone in the other flight and they can wave back. We were that close and it's fun. And these are various instruments installed on aircrafts. All are basically first contact part of an instrument, because you cannot simply have a pipe coming into your experiment, because then there can be ice particle coming in, there can be pressure differences, preconditions, some precondition need to be done. So all these equipments are very sophisticated, having different parts. They need to be strong enough to face strong winds, because flights, as you know, fly at very high speed, rigid enough, sustainable enough, and they should have a support system so that you have an actual sample which can come to your instrument and then that can be analyzed. So these are various pictures. Again, you can see holes drilled in the body of aircrafts and piping being brought in. Then seats and instrumentation panel. One of my colleague working with one of the instruments. And as I said, flights flying together. How many times you get a chance that you are in one flight and you can take a picture of another flight, except in airports? We were over Atlantic and taking these pictures, and we were flying more or less parallel to each other. And that's where I end my presentation. I hope some of you might have enjoyed it. Some of you might have already known many of these things. Thank you very much. And if you have any questions, please ask me.
This is a really wonderful talk. So this is completely different kind of talk about your experience on actually expectation of.
I call it Sholay.
Yeah.
Because it has all those masala for a super hit presentation.
Yeah, just Penderson, but what kind of research you means research point of view how it
I did.
actually.
Yeah. So my research, I was there for the study of greenhouse gases and ozone hole. So in a bigger picture, climate change, global warming research when it comes to the measurements of greenhouse gases, because we need to continually monitor CO2, methane, ozone in the atmosphere, so that we can use those data for model validation and predictions. And similarly, ozone hole, as you know, now it's not that hot a topic, but during almost from end of start of 90s, it was discovered in 88, 89, and till recently, it was a global threat. And that's why everyone pitched in, and globally, Kyoto Protocol is the protocol which addressed ozone hole, and all the CFCs and ozone depleting gases were banned. And probably I played a very small part in that bigger picture, because I was doing my total ozone and stratospheric ozone measurements in 2004 in Antarctica.
Okay, thank you. So if participants have any questions, they can write in chat box, or if they want to ask, they can raise their hand. We can unmute them so that they can interact with Dr. Kulkarni directly.
I already exceeded my time, so if you are all bored with all this stuff, please excuse me.
So there is no questions.
Probably yes. Already people might be sleeping. Sorry, it's a popular joke.
So one thing is, sir, do you think that ozone hole will going to get repaired?
Yes, for sure. It will take some time. We know all the science. We know the methodologies. Only thing is in the atmosphere, processes are slow. Still, CFCs and long-lived gases are there. Ozone depleting gases still exist in the atmosphere. Still, we don't get removed all those gases from the atmosphere, and all other dynamics and global warming plays a proper role in ozone hole. So if things can get all these things come together in synergy, definitely we can get rid of ozone hole. I don't know about global warming, but I'm sure about ozone hole. It's already in the recovery phase. It's not that it's not recovering, but the process is slow and definitely it's going to take time because it's not formed in a day, so it will not get recovered in a day. And ozone hole is not there all the time. It's a seasonal phenomenon. It starts with first ray of sunlight, ozone starts depleting. It peaks somewhere by the end of November, depending on dynamics, mid of November, end of November. It stays there till end of December, and then again it breaks off and it disappears by end of January, start of February. So it's a 5 to 6 weeks phenomenon, but it depletes lot of ozone and overall thickness of ozone layer starts decreasing, which need to be avoided because ozone is very important stratospheric gas because it screens of harmful UVB radiation. But yeah, I am very much optimistic that this problem of ozone hole, at least in my lifetime, if I live long enough, will get resolved.
So what is the main reason for actually it's getting resolved? So earlier there are many gases and many things because of that reason ozone layers actually depleting. But
See,
what
there
is the
are
main reason?
it's a heterogeneous reaction. The problem is ozone hole doesn't get formed because of one pinpoint problem, but it has 5 ingredients that come together and form ozone hole. One is long Antarctic winters when there is no sunlight, because of which the temperature falls to a very low level, even in the stratosphere. And then there are formation of polar stratospheric clouds. Polar stratospheric clouds are clouds formed in the stratosphere. And then they have ice crystals. Okay, so these are physical things. Then the CFCs, there are so many different kinds of CFCs which reach stratospheric height, and then uh, they need a substrate. So ice particles provide this substrate, gas comes and sits on top of it, and then you need energy in terms of photons. So sunrise occurs. So all these ingredients come together, and then this chlorine gets detached from CFCs. And
No,
this
no.
chlorine,
The main question was, so why started decreasing, ozone layer decreasing, and now again it is recovering, you are saying.
yes.
What is the main reason? What is the human interference or what the main reason? Maybe
So
CFC or some other reason?
yes, that's what I'm saying. You need to break the chain. I said you bring all these things together, ozone hole starts. You remove one component and there will not be ozone hole. So what happened is through Kyoto Protocol and then subsequent protocols, CFCs totally got banned from the use. Now, no more you can use CFCs in your refrigerators and as a coolant or in deodorants and everywhere. So the main source of chlorine in the atmosphere was cut short. Whatever was already released will stay for almost like thousands of years in the atmosphere, but they need to reach to stratospheric height, which takes lot of time, and then they need to uh, get proper atmospheric conditions to deplete it. So one major source, that is CFC, which is man-made, is completely stopped. So now the dynamics plays its own role, and slowly all these CFCs will get rid of, washed out of the atmosphere, and then the healing process will start.
So one question from Annu Kumari.
Yeah.
Sir, each Kyoto Protocol and Helsinki Protocol are applicable properly by the countries. Sir, what is the alternative of CFC?
Tricky question, but I will answer that because I know partially answer to that. See, laws are always made, and there is always a bypass to that. Now you must be knowing means that mixing kerosene into fuel, petrol particularly, was a very common phenomenon a decade back. But then government came up with a rule saying you cannot mix petrol into diesel, kerosene into petrol. They colored kerosene blue, blah, 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 all those things happened. So on a large scale, that stopped. but at a very small scale, somewhere it's still prevalent. Similarly, CFC has been totally banned. As of now, in 2020 onwards, there was a phasing period. It doesn't stop suddenly. Developed countries were asked to stop their production by 2000, and developing and underdeveloped countries were given more time to get into the technology, develop technology, and slowly phase it out. But as of date, 2020 was more or less the deadline for all countries to completely ban licensed production of CFCs, which is there. But still, in some small part of the world, somewhere, if there is some stored CFC which was not utilized, or someone has black marketing, but these things now happen at a very small scale. Okay, and alternative has come. HCF have come. HCF are alternative to CFCs. HCF has a weaker bond compared to CFCs. When CFCs were discovered, they were considered as noble gas. We realized after 2 decades that they are not noble. In fact, they are the devils. Now we have came up with HCF. H has a very weak bond with carbon and remaining chlorines. So this breaks off. And the moment it breaks off in the troposphere itself. Their lifetime is small and their bondages are very small. So all that HFC get remained in the troposphere, it never reaches stratospheric height. But, and they are cheaper option to CFCs. But still there can be few equipment that just runs on CFCs, and some black marketer trying to take advantage of that. That will be there. But that's very fraction of what was the global consumption of CFCs. So that is getting dealt by. And
Okay.
will this problem be solved? Yes.
So another question is, what is the difference between stratosphere and stratopause? So,
Okay, now we are entering into atmospheric dynamics. So we start from surface of the earth. First few 1.5, 2 kilometers, depending on season. Just don't quote me somewhere saying Pawan Kulkarni sir said 2 kilometers. It's not that straightforward. Depending on season, location, first 1.5, 2 kilometers is boundary layer. Above that is your troposphere, up to 9 to 15 kilometers. In polar regions, 9 kilometer to 10 kilometer. In equatorial region, it's 14, 15 kilometers. And then there is a small layer called tropopause, which extends for next 2 kilometers. Then comes stratosphere. And then there is again a small envelope of kilometer or 2 kilometer, that is called pause. So a layer that is differentiating between two spheres is called pause. So you have tropopause differentiating between stratosphere and troposphere. Then you have mesopause that is differentiating between mesosphere and stratosphere, and so on. So whenever you hear a pause, tropopause, stratopause, it's consider this as an envelope separating a membrane separating two different layers. It's the easiest I can say. And if you send me something, I can send links or books on this. Any more questions?
no more questions. So it's all question done. So thank you very much.
Thank you very much. Nice audience. I hope everybody
People
enjoyed
have
this
asked questions, so at
presentation.
least they are listening and doing the things. That's good, symbol. And thank you, Pawan Kulkarni. So thank you for
Thank you
nice
very much.
talk. So
Okay.
you're welcome.
Thank you. Thank you, everybody. And have a nice day.
Okay, thank you.
Can I put it off?
Yeah,
Yes,
sure.
sir.
Yeah, please. Thank you.
So participants, today's day 9 session is over for today, and we are having a quiz
So
Which
it will
will
be
be
online Google Form quiz, no? So that's fine.
Yes, sir. So I'll be sharing the link for the quiz, and you can attend the quiz at your at any time that is available for you, but you have to submit it before 3 p.m. So I'll be sharing the link in the chat section, and you can also find the link in the course material folder.
Yeah, and for tomorrow we have one session by Amit Joshi, what is table in latex and general documentations, and
Yes.
then at 12 we have a valedictory session and keynote speech, both at by Dr. Mukul Kanitkarji and Gaurav Trivedi. And so we have actually Mukul Kanitkarji actually is very good once orator. He can actually describe things very nicely about he is part of Bharat Sikhan Mandal and NEP. Issue data in his keynote speech. So tomorrow we have around 12 p.m. So we have his speech, and after that we'll have a validity session at 1:30 p.m. So see you tomorrow at 10 a.m. Okay. So thank you. Thank you all the participants. Thank you.
Thank you, sir.
Yes. I'm logging out.
Yes, sir. Thank you, sir. So participants, you can access the quiz from the link provided in the chat section. You can use the, if you are using from mobile, then you can go to the course material folder and announcement page. Over there, you will find the link of MCQ2. Yes, you can leave the meeting, but in case if you are not finding any difficulty in accessing the quiz, you can please ask me the question in chat section. I am here for another 10 minutes. And after that, I will also be ending the meeting from my end. So if you are finding any difficulty, if you're having any difficulty, you can just leave a message in the chat section. Hello, ma'am, you're unmute. Akansha Pandey.
हाँ जी जी सर।
हेलो
सर लिंक नहीं, लिंक नहीं मुझे अवेलेबल दिया है, इससे मैंने हैंडल किया था।
मैम, your voice is breaking. I cannot understand whatever you're saying. Can you please write it in the chat section?
सर लिंक अभी मेरे को नहीं मिल कैसे इसमें आप लिंक डाल रहे हैं? हेलो
लिंक आपको नहीं मिला है?
हाँ जी
मैम, आपके पास वो कोर्स मटेरियल वाला फोल्डर का लिंक है ना,
जी जी
जहाँ पे अटेंडेंस का भी फाइल है, तो वहां पे जाइए, वो
हाँ
अनाउंसमेंट वाला फॉर्म में जाइए, उस फॉर्म में आपको लिंक मिल जाएगा। और मैंने ग्रुप में भी डाला
ओके
हुआ है,
सर
टेलीग्राम ग्रुप में भी दिया हुआ है लिंक।
ओके
ये
ओके
अनाउंसमेंट, इम्पोर्टेंट अनाउंसमेंट बोल के जो पेज है, उसमें क्विज 2 लिंक आपको मिल जाएगा। ओके मैम। So if there are no more queries, then I'll be ending the session from my end. So for further queries, you can drop a message in the Telegram group. I'll be active there. Can you please share the link for the course folder? Okay. I have just shared the link. Can you see it in the chat section? In the course folder. It's course folder. Yes, I have already shared it in the course folder. In the announcement page, you will get the link. So thank you, participants. Tomorrow we will be having our last day of our 10-day workshop. So hope to see you all at 10 a.m. tomorrow. Thank you all.